All right, here we go. Yes.
Is this like a new unit? So we're done with limits?
Yeah, well, we're not done with limits, but new unit. All right, here we go, guys. The word that we've been wanting to use all this time. Yes, yes. No, it's okay. You're good. I have. Oh, I got a lot digitally, and then I got some here. Do you want me to send you the digital one?
Oh, sure. We really just need to know if there's any missing.
Yeah. Let me see. Which ones do you need?
I can take your photo releases too, about the handbooks, the student handbooks.
Okay, and then I got some more. Can I send you an email today?
Yeah. That'd be fine.
And I'll just attach them, all the digital ones that I got. I'll download them and attach them to you.
Sorry to interrupt.
No, you're good. You're good. The word derivative. This word comes out all the time, especially the word derivative means something that, well, it means kind of the same, but not in the stock market. But the word derivative in calculus, check it out. What is, do you see something that you recognize?
Is that a limit?
This is what you call derivative. So yes, when you were finding your tangent slopes, you were finding derivative at a value, at an x equals a coordinate, at a coordinate. Sorry, I can't talk today. So when you were finding derivative, you've been using this. You've been finding tangent slopes at least, what now, 2 weeks?
Yeah.
So you've been finding derivatives. So notice that it has the x here and not a number or a letter like an a. So that means that the expression is called a derivative. And then if we plug in a value, then that's the derivative at x equals that, whatever value that is. Cool? What's up? Oh, it's notation for derivative. So we call this prime. And there's a joke, like what's the derivative of a cow? And they go prime meat or something, or prime something. I mean, I guess it's funny. And the math nerds will probably like it. Yeah, this little prime here, that's how you say f prime. And it stands for first derivative. Cool? Okay. Is there higher than first derivative? Yes, but we'll talk about that later. Here we go. So it says, example 1 says the word differentiate. And differentiate means to take a derivative. Find the derivative. So we want the derivative of 3x squared. So we're going to write f prime x is equal to f of x plus h minus f of x all over h. That's what well, I forgot to do what? Yeah. Put the word limit in the front. You have to put the word limit because we haven't evaluated it. I'm sorry, guys. Bad notation on my part. Put the word limit in the front. So here we go. I'm going to find out here on the side, I'm going to write f of x plus h is equal to 3 parentheses x plus h close it squared. Hopefully we can do these pretty fast now. 3 parentheses x times x is x squared. X times h is xh. You're going to have two of those, so 2xh. And then h times h is h squared. Distribute the 3. So 6x squared plus, oh man, what's wrong with me? 3x squared plus 6xh plus 3h squared. Are we all right so far? All right, hopefully today won't be a mistake-filled day. I did get sleep and I feel okay. 3x squared plus 6xh plus 3h squared minus f of x, which is 3x squared, all over h. What's going to cancel out? The 3x squares cancel out, and now I just have h's there. So now I can factor out an h. So I'm going to keep writing the word limit. So some of you guys are forgetting to write the word limit. We didn't take points off, but make sure in the free response that if you haven't evaluated it, you continue writing the word limit. 6x plus 3h minus 3 all over h. H's cancel out. What is h approaching?
Wait, yeah, 3h.
Well, it was 3h squared, right?
Because they canceled out.
Oh, yeah. Man.
You should never stay up late reading.
I'm making so many mistakes. No, I'm going to be better now. Okay. You know what? Let me chug this coffee. Guys, let's not promote any type of plan. I'm definitely going to have to edit the video now. Because the last thing I want my boss is to... Guys, come on, focus. All right, here we go. Now that h is approaching 0, what do we get? That's it. So, here's how you label it. You go f prime of x is equal to 6x. And that's it. So the derivative of 3x squared is? Okay, now check it out what I'm going to do. Because I didn't type out. Now, let's say I wanted the derivative at 2. So I'm going to write f prime of 2 equals, all I do is plug in a, what is 6 times 2? So my tangent slope at 2 for 3x squared is 12. And if I wanted a tangent line, I could. But I'm not worried about that right now. Cool or not cool? Okay, so this is my derivative. Yeah, all I did was plug in a 2. If I told you what is f prime of 2, or what is my tangent slope at 2, my tangent slope at 2 is 12. This one right here, f prime of x, that's called your derivative. And the f prime of 2 is called your derivative evaluated at 2. Or you could also say your tangent slope at 2. Or instantaneous rate at 2. If this were a position graph, you would say velocity at 2. Cool or not cool? Okay, let's go to the next one. Yes.
Oh, wait, I'm sorry. Where did you get the 2 from?
I just made it up. I said if I wanted f prime of 2.
It was like an example.
Yeah.
Awesome.
Oh, you're good. All right, so look at the alternate definition. They both mean the same thing. Now, notice this one doesn't have, it says f prime of a, not f prime of x. So this one's just going to get you that number directly because we're evaluating it at a point. And it's the same. I could have done evaluated this at a point immediately if I would have done f of 2 plus h minus f of 2 over h, limit as h approaches 0. This is being evaluated at a point also at 2. Does that make sense? All right, so we're going to do the same thing, and this is why I decided to make this one up, because I want to evaluate it at the same, it's the same coordinate.
Isn't that one kind of just like y2 minus y1?
Yeah, it's the same. They're actually, this is pretty much the same as this here. It really is, right? Remember when we did that delta activity, and one of them said table with an h, and the other one had x approaching like 4.1, 4.01. It's the same concept, same thing, but written differently. So here we go. So check it out. This one says find the derivative in example 1 again, this time using the alternate definition. So I want to find, and I did a really bad job of writing these notes, I want to find f prime of 2. But I'm going to use this definition, not the other definition. You know what I mean? So I'm going to write f prime of 2 is equal to the limit as x approaches 2, because that's the number I want to approach, of f of x. What was f of x? 3x squared minus f of 2. So I got to write that down on the side. F of 2 is 3 times 2 squared. 2 squared is 4. 4 times 3. So write 3x squared minus 12 over x minus 2. I haven't done anything.
Oh.
All I've done is this part right here.
Oh.
Is everyone okay?
So you plugged the 2 back into the original equation?
Yeah, f of a, I just plugged in a 2. If maybe there's confusion because I didn't type out this example properly. I'm using my alternate definition at x equals 2, and maybe I should have told this question also semicolon find f prime of 2 as well, and I did. So next time I'll edit. Next time I'll edit the notes better.
So it's
A is 2.
So A is your point.
A is an x coordinate. Yes,
Oh, because this one it's f prime A, not f prime.
correct. Not f prime of x. F prime A.
But if you want to see this equation, they would give us f of x, right?
Mm-hmm. They're always going to give you your f of x. Any other questions, guys? What's up?
So in the first definition, they were asking us to find
f prime of x. Yeah, just the derivative, which is just an expression.
They're asking us to find a specific.
They're asking us to find the derivative evaluated at 2. They didn't say 2. I typed out when I was typing this out, I thought I was typing them out awesome, but obviously I typed them out pretty bad. Yeah, you're right. Maybe I should get sleep. Okay, here we go. You guys ready? I'm going to factor out a 3. Limit as x approaches 2. There's my 3 factored out.
You have to keep writing the f prime.
Well, I already have it on the left-hand side. I mean, if you wanted to keep writing it, but I'm going left to right, and I have an equal sign, so it connects everything. There's my x squared minus 4. Hopefully there's red flags. Well, not red flags, green flags. Green flags. Hopefully there's green flags. X squared minus 4 is perfect. So I'm going to write equals limit as x approaches 2, 3 parenthesis x minus 2, x plus 2, all over x minus 2. What's going to cancel out? Now that I've canceled out the x minus 2's, can I do direct substitution? So here we go. F prime of 2 is equal to 3 times, what is 2 plus 2? Oh, what's 3 times 4? Did we get the same answer as we did earlier? Yes. They will both give you the same answer. They're just alternate definitions. Yes.
What did we do with the x plus? Oh, never mind.
I plugged in 2 in there,
Yes.
into the x.
Like instead of doing the x plus h, could we have just like done that?
Yeah.
I'm
We,
a little upset.
well, you don't be upset because you did a delta on this, like,
Oh,
you know.
you're right, you're right.
All right. So the notation for derivative. Here's your notation for derivative. No, relax. A little prime symbol there, and you say it y prime. That means derivative. Like that. When do you use this one? If I tell you y equals 3x squared, then you would go y prime equals 6x, like what you just did right now in example 1. Cool. You can also say dy dx. So how do you dy dx or the derivative of y with respect to x? Yeah. So if I write y equals 3x squared, you can go dy dx is equal to 6x. Hopefully you're not shocked. Don't be scared. Remember that. Okay, how do I make sure that we don't get scared? Remember that derivative means instantaneous rate of change. Notice that doesn't that look very similar to like slope? It actually is. Dy dx, really this means difference in y over difference in x, but we're talking about infinitesimals. So what's the difference between this and this? This right here on the left, and I probably should start using the word this. The delta y over delta x on the left, that's like just for anything. Like we're the change in y over the change in x, and if we're talking about big numbers, then so be it. Those are big numbers. When you see dy dx, now we're talking about instantaneous rate of change. So think of that dy as a super small change in y over a super small change in x. We're talking about instantaneous rates of change here. Like if you're zooming in on a graph and, oh, what's that slope? Does that make sense? So that's where this notation came in. By the way, the inventors of calculus were Leibniz and Newton, and we're using their notations. df dx, that just means if you get a function f of x and you write df dx, that means you took the derivative with respect to x. You took the derivative of the function f with respect to x. It took the derivative of what? That with respect to what letter? X. Yeah, these are all ways to say the same thing. ddx, put a parenthesis like that. Whenever you see ddx, they're just saying, I'm taking the derivative with respect to the letter x for the function f. So if you see me go like this, ddx, and you see me write 3x squared, that's the example 1 that we had, you're going to tell me, what are you going to tell me? 6x. You can
still calculate it out once.
Yeah,
Doing this.
yeah. For now, and depending on how fast we are, you're gonna see something, and you'll probably be mad. Or for now, we have to do all this work. Later on, it'll get easier. Cool or not cool? Or you might notice a pattern maybe in a little bit. I don't know. All right, example 3. You guys ready? I want the derivative. The derivative of this function here. Chavez, I don't know. All right, let's start. Your algebra is what's going to hurt you. So algebra is king or queen, I don't know, whatever. Algebra is the key to all this. Without algebra, calculus is simple. So, Chavez, I know how to find this. Okay. F prime of x is equal to limit as h approaches 0, f of x plus h minus f of x over h. I think by now everyone has that memorized pretty much now. There, that's the calculus part. Now comes the algebra part. Okay, f of x is square root of x. Let me go ahead and write f of x plus h equals square root of x plus h. And that's it. You can't do anything about that. So here we go. I'm going to write f prime of x equals limit h approaches 0. And I'm going to write square root of x plus h minus square root of x over h. Hopefully by now we should start reaching, and we've had enough experience, I think by now, we've had enough experience that something should tell you what is right to do. Multiply by the conjugate, see? So now we're there where we are getting enough experience. So square root of x plus h plus square root of x over square root of x plus h plus square root of x. That in blue is still 1, so you're still multiplying by 1. Are we still okay? Oops. Okay. Yeah, there we go. So here we go. Can you guys see that, or is it too small? Okay. So when I distribute, we're going to get, let me see, limit h approaches 0. This is like the difference of squares, a minus b, a plus b. So you don't have to FOIL. You can just multiply the ends already. So square root of x plus h times square root of x plus h, that is going to be x plus h. Square root of x times square root of x, that's going to be x. So just put minus x there. All over in the bottom, some of you are forgetting to bring this. That's where I gave partial credit because some of you guys forgot to bring this. Just write, don't distribute the h, just leave it as x plus h minus plus square root of x, like that. Okay, here we go. What zeroes out? Now that you've zeroed out the x's, can I cancel the h's out? Yes. Bam, bam. Now that you've done that, here we go. We still haven't evaluated the limit, so I'm going to keep writing the word limit. I'm going to write f prime of x is equal to limit as h approaches 0 of, let's see, a 1 over x plus h plus square root of x. Okay, square root of x plus h plus square root of x equals, I'm going to go ahead and evaluate the limit. H is approaching 0, so I have 1 over square root of x plus square root of x. How many square root of x's do you see? So 1 over 2 square root of x. That is the derivative. How do we feel, guys? Yep. Yes. I would prefer, if they give you f prime is the best notation. You could also say d dx of f of x, but I think this is the best.
So either number 1 or number 4 on that?
If you label these as 1, 2, 3, 4, I would say either 3 or 4. Or, yeah, number 1 if you want to count that as the same as. Yeah. Cool or not cool, guys? All right, let's see. Ready for another one? Now we have this one here. And I think we've done this one who knows how many times. So let's see. F of x plus h is equal to 1 over x plus h. We're ready to rock and roll. So we're going to go f prime of x is equal to limit as h approaches 0 of 1 over x plus h minus 1 over x all over h. I can't subtract them in the numerator unless I have a common. So I'm going to multiply the right term by x plus h over x plus h. I'll multiply the left term by x over x. So now we're going to have limit as h approaches 0. Let's see. X over, I wouldn't distribute it, but if you want to, that's fine. x plus h minus x plus h. In a little bit, we'll distribute the negative. X parentheses x plus h. And all this is still over h. Get up to here. So here we go. Equal sign. The word limit as h approaches 0. X minus, so I'm going to distribute this negative here. Negative x minus h. So minus x minus h all over x parentheses x plus h. Close it, and I'm bringing up that h. H. Are we okay? Okay. What zeroes out? The x's. Now that the x's have zeroed out, can I factor out an h? Or can I cancel out the h? Sorry. Yeah, that's better. So h's cancel out. And h is approaching what? 0. So here's what I have. I have a positive 1 in the top. Oh, negative 1. Negative 1. Yeah, thank you. Negative 1 from right there. And then h is approaching 0. So what is x times x? So there it is. A negative 1 over x squared. So I'm going to write f prime of x. My derivative of 1 over x is a negative 1 over x squared. I was testing you guys about that negative. No, I wasn't. It just happened. Yes, miss.
So is this like, this is technically the same thing that we've been doing while we're adding
Yeah. It's the same thing we've been doing all this time. We're just adding the expression f prime, saying derivative.
putting in a specific point.
And yeah, and instead of putting it in a specific point, I'm just f prime of law. Now, if I had told you what's my tangent line of f of 1 over x at x equals 3, you plug in a...
1 over 9.
Yes. And if I wanted like my tangent at 2, 3, and 4, it's probably better if you do f prime of x and then 2, 3, 4. Cool? All right. Let's see. Do we have some more? All right. We got another one. You guys want to see if you guys can do this faster than me writing it up here?
We already know the answer to that.
No.
We've been doing this for like what?
No, it's oh yeah, that is true. But yeah, you guys go ahead and get started. I'll go slow here. No, I'm going slow.
Give us a 10-second head start.
Yeah, no, I'm going slow, miss. 5 parentheses. Well, I'm going slow, guys. I promise. Look, x times x is x squared. X times h is xh. So you're gonna have 2 of those. H times h is h squared. Then distribute the 5. So this is 5x squared plus 10xh plus 5h squared. See? And now we're ready. F prime of x is equal to the word limit as h approaches 0. I'm going to do f of x plus h, which is that expression on the top. 5x squared plus 10xh plus 5h squared. And I'm going to subtract f of x, which is 5x squared. All that is over h. Guys, I'm not racing, guys. It's not a race. You're going to zero out the 5x squared. See, I already see some of you already finished. And then now that all the terms have an h on them, I can cancel out one of those h's. And h is approaching what? 0. So then that means I'm going to have just 10x. So my derivative is just 10x. No, I know how to do it, guys. All right. Cool or not cool? All right, let's see. What else we got? Look at this one.
Wait a minute. That is a normal line. Something is wrong here.
No. Take it. Okay. Yeah. So check it out, guys. So let's see. We don't want to be robots. When I do my calculations for derivative, because remember what derivative means. Instantaneous rate of change. What should I expect when I take the derivative of this? No, not 7x. Just 7 everywhere. Because I have a linear line of 7x plus 5. That slope is 7 all the time. It does not change. So no matter what x value you're at, it's always going to be 7, the slope of the tangent line. Do you guys see that? So I'm going to go ahead and continue doing my formula. And it should not be a surprise that we get a 7. So let's make sure that we're not robots. So here we go. F of x plus h is 7, parenthesis x plus h, close it, plus 5. Distribute the 7. So f of x plus h is 7x plus 7h plus 5. Nothing combines. So here we go. F prime of x is equal to the word limit as h approaches 0 of 7x plus 7h plus 5 minus, parenthesis, 7x plus 5. We'll distribute it in a little bit all over h. So here we go. Next line, f prime of x is equal to limit as h approaches 0. I'm going to go ahead and distribute this right here on this line. 7x plus 7h plus 5 minus 7x minus 5 all over h. I'm going to cancel out or 0 out first. So the 7x's 0 out, and then the 5's 0 out next. And now I just have one term. That h cancels out with this h, and it is no surprise that all you have is 7. So my derivative is just 7 always.
So is the reason that the one that was squares instead of 10x is because it would never be like another x or something? Does that make sense? Or,
Yeah, I think you're trying to figure out a pattern.
Yeah.
So you're noticing that quadratics, when you take a derivative, it's just going to be a linear. All right, now you're starting to see patterns, miss. You're starting to... No, they're... So get out, notice something. Yeah, get out, notice. She's like, wait a minute. 5x squared, derivative is 10x. And then she went over here to the other one, and she's like, wait a minute. Derivative of 3x squared was 6x. But hold on, no. We're not there yet. There is something there, but let's not get there yet. All right, is that the last one? Okay, we have an activity. Let me stop this.